Pardon me, I was not recording, so I have to start over with metallic bonding. Okay, let's go. So with metallic bonding, we have in our diagram there with the metal lattice, we have metal cations, and we have a sea of electrons that move around, and they form what is called a metallic bond, which is very strong. So there in our diagram, that represents the bonding in metals, right? So these delocalized electrons, meaning that they're not attached to any specific cation, they're free to move around. So they form a sea of delocalized mobile electrons, and this forms, and the metal lattice is held together by the electrostatic forces of attraction between the delocalized electrons and the cations, and this in turn forms what is called a metallic bond, which is very strong. So we're going to move on to properties of metals. None of my students are answering. Anyway, we know that metals have a high melting point and boiling points, right? Why? Because the strong electrostatic forces of attraction between the cations and the delocalized electrons require large amounts of heat energy to break. Because the metallic bond is so strong, it requires a lot of heat energy to break, and this is why metals have a high melting point and a high boiling point. And why are they solid at room temperature except for mercury? Because room temperature is not high enough to break the strong electrostatic forces of attraction between the cations and the delocalized electrons, we find that most metals except for mercury are solid at room temperature. They also have a high density because the atoms are very closely packed together. We know that metals conduct electricity. Why? Because we have electrons that are free to move and they can carry electricity through the metal. We know they conduct heat also. Here again, the sea of electrons, they move and they can carry heat through the metal. Metals are also malleable and ductile. Malleable meaning they can be hammered into different sheets, and ductile means they can be stretched out into wires, right? The atoms of each metal are all of the same type and size, and if force is applied, the atoms can slide past each other into new positions without metallic bonds breaking. So that will bring us to the end of our work on metals. I want us to go through our work on writing chemical formula, right? So in a compound, I'm going to give you one right here. In compounds that are formed, we can represent a compound using what is called a chemical formula, right? For example, let's take a simple one, the table salt that we know. Table salt, NaCl. This is table salt, right? How do we arrive at NaCl? Simple. We know table salt is called sodium, right? Sodium. Pardon my fancy writing. Sodium. What is table salt called? Sodium what? Chloride, right? CH. Sodium chloride, right? So how did we arrive at the name sodium chloride? Basically, we combine the two atoms, the two ions that make up this compound. So the first ion is what? Sodium. So we're going to look at our chart here. This is sodium here. Sodium. So we put Na plus. And we have, wow, I know what fancy thing they're doing there. Na plus. Na plus. And the chlorine now, we're looking for chlorine. This is chlorine down here. Chlorine, right? Sodium chloride. So this is the chloride ion we look for. Chloride. Chloride, right? So what I like to teach my students is that we can represent the positive charge as one hook, right? And the negative charge as another hook that bonds with this positive hook. So we end up having NaCl. And this is called the chemical formula of a compound. So this is your first example. So take down this for me. You're going to write the name of the compound. Let me take off that part that I have. Write the name of the compound. So your heading is chemical formulae. Let me write the heading there for you. Writing. I know I can't write this thing too good. Writing. Please take down your heading. I told you to have pen and paper, right? Writing chemical formulae. That's her heading. Are you guys taking down your heading? Formulae. Good, so that's your heading. And this is your example 1. Writing chemical formulae, that's your heading. Sodium chloride. So I started to show you how to write the chemical formula. So from the name of the compound, we then look for the ions and then we bond them together. They are bonded in such a way that each positive has a negative partner. And this is why we end up with NaCl. Any questions so far? Please take down your first example. All right, have you taken down your first example? Hello? Somebody open the mic and respond. Have you taken down your first example?
Bigger. I don't know. Yes, please.
All right, so let's move on. Example number 2. Let me give you number 2. So number 2 is going to be slightly different, right? So we're going to take, let me take this guy out and out. That's your heading. All right, so we're going to start with, let's take sodium. Not a sodium compound. SO. D I U M. Sodium, and we're going to take sulfate. Notice they have FATE, right? But it's not, normally it's PHATE. That's the American spelling. So this is number 2. So we're going to work number 2 now. Number 2. All right, so we know this is sodium here. So we write Na plus. And we have one hook. We represent it as one positive hook, right? And we look for sulfate now. Somebody drawing on my board. Anyway, yes. So we're looking for sulfate now, and this is sulfate here. That's sulfate, right? Sodium sulfate. So we can put SO4. Two minus, right? But notice we have one positive and two negatives. So what are we going to do here? This is one negative stroke here, a hook. And we have another negative stroke, but this one is without a part now. So what we can do? We're going to add another sodium atom, Na, right here, to get another positive hook to cancel off this negative. So in our compound, we must remember that the positive charges and the negative charges have to be equal. So this two will be canceling out this other negative. Do you understand? Because this negative was without a partner, we added another sodium atom and we cancel off. So we have two positives now and two negatives. So how are we going to write our formula now? Let's write our formula now. Na. How many atoms of sodium y'all see in this compound here? From here, how many atoms y'all see of sodium? Come on, students, open your mics and answer. We're in class. You have to communicate with me. How many atoms of sodium do you see here now? This is one and this is one here. So we have two atoms of sodium. But we have one atom of sulfur here. This is one atom. So the chemical formula for sodium sulfate is Na2SO4. Yeah. All right, SO4. Sorry about that. So do you understand how we got this formula here for sodium sulfate? Please open your mics. Let me know what's happening with you guys. Hello? You all understand?
Yeah,
Damari, you understand?
Yeah, miss.
All right, take down your example, sodium sulfate. We're going to do another one just now. I'm going to get a little bit more complicated. That's as complicated as it gets. Go take down your example. Note, you have to know these ions to be able to write your chemical formula. So y'all got some work, right? Y'all got to memorize these common cations and the common anions on page what? Page 34 in your textbook, right? So tomorrow I'll be giving y'all a quiz on these different ions. right? You're gonna memorize them, learn their names, etc., etc., and their how they're written. Good. So write your example. Sodium sulfate. So did you get to write down your example? I hope you did before I did something else and lost it. Anyhow, let's go. So we're gonna do this one. See if let's see this one. Aluminium. This is 3, right? Example number 3. So we're gonna look for aluminium oxide. And this is as complicated as it gets, right? Don't get more complicated than this one. Good. So we look for aluminum here. This is aluminum. Al. And we have 3 plus, right? And the oxide, we go down here. This is the oxide here. Oxide. Let's look at now this thing. 2 minus. All right. So we're going to match up. We have to keep adding atoms until we have all the hooks matching up. So we have 3 positives. We put 3 positive hooks here. 1 there and then 1 there. But notice we only have 2 negatives. So this one can cancel out and this one. But we need another oxygen. So we add another oxygen. 2 minus. Good. But we have 2 negative hooks, right? This one cancels out. And another negative hook. But this negative hook doesn't have a partner. So what do? We add an aluminum here. Al 3 plus. We add another atom of aluminum. So we're trying to cancel out these guys, right? So this negative is canceled out. But remember, aluminum has 2 more hooks. It's 3 in all. So what are we going to do now? They have the positive hooks without partners, so we add another oxygen. Look a little bit complicated, right? But it doesn't get more complicated than this. So we cancel out this positive and this positive. So now in all we have 6 positives and 6 negatives. So we're going to write the aluminum formula now. Al. How many Al atoms do we see here?
6.
No. The atoms are these guys. Not the charges. The atoms are these guys. How many y'all see?
3.
No, oh yeah, see. Oh yeah, look, something wrong with your eyes or woman. Al2, right? And how many oxygen? You get this oxygen, you get this one, you get this one. How many oxygen in all?
3, miss.
3. So we put O, 3. And this is as complicated as it gets. So this is the chemical formula for aluminum oxide. Yeah, I think you understand this one? You just keep adding the atoms. How you get what?
Miss, I get 2.
Aluminium? Because you
Yeah.
have to add this other one to cancel off the negatives here. You get this one and this one. That's it, count the 2. And the oxygen is 1, 2, 3. So that's how we get the Al2 and the O3. And this is the chemical formula for aluminum oxide. I'm going to give you a couple to work. So let's see what they have in the textbook. Let me see if I can give you a couple to work for next class. We got 4 minutes leaving for this class. I'm not going to hold y'all longer. I think that's enough content for today. Y'all learn enough. We're going slowly but surely. We're getting there. Oh shucks, I didn't even let y'all write down the example. Y'all didn't get to write it. You understand?
Yeah,
though?
miss, I don't write it. I don't
you don't
write
write it. Praise the Lord. I don't
No.
erase it. Somebody send a pic in the group for the people that didn't get to write it. Sorry. All right. Anyway, let's see. I'm gonna give you an exercise to do. Looking for the end of chapter exercise. Let's see. Let's see what they have for the end of chapter exercise. I was checking to see if they have anything there. Chapter long, man. Oh. Good. So look these here. Question 3. Determine the formula. The formula they're talking about there is a chemical formula I was telling you about that we were doing just now. Determine the formula of each of the following compounds and state how each would be bonded. But you're just going to write the chemical formula for me. You're going to do zinc chloride, B, magnesium phosphate, silicon tetrafluoride, carbon disulfide. Try all of them: ammonium carbonate, aluminum hydroxide, and potassium sulfate. So you're going to do A to G for Wednesday's class, right? Yeah, going to practice with this. So please take a pic of your questions that you have to do for Wednesday class. Remember, it's Monday and Wednesday, and Monday we can miss because what we can do the class on Tuesday after Easter Monday. We can do Tuesday and Wednesday next week. So that's it for today. Right? Please take a pic of your question you have to work.
Miss is A, B, C, D, and to G.
A straight down to G. You're trying all of them for practice. And remember, you have to memorize your ions on page 34. These ions are what you're going to use to write your chemical formula. Look them right there. Page 34. Yeah, these guys. So these are your guide. The common cations and the common anions. And that's it for our class today. I hope you enjoyed your class. Not too troublesome with too much content. It's just to keep something to have you, so we can keep going and not have a lot of work to cover in Form 5. Want y'all to cover this work so we can cover the syllabus. We can have loud time for practice questions so you can be fully prepared for your exam. All right, so do enjoy the rest of your day. We're going to stop here for today.
Okay, miss.
Mm-hmm.